a little quick review on limits. Let's say you've got the limit as x approaches 3 of x squared minus 9. Again, we've talked about it several different ways, but you know what this graph is. This is a parabola. This happens to be a parabola that's dropped 9 units down, but it's a parabola. But if you want to know what the limit is, you just plug in. You say, okay, well, it's 3 squared minus 9, which is... Sorry, don't need the limit once I plug in for x. I don't need to continue writing that. So it's 0. All right, so 3 squared minus 9 is 0. So the limit as x approaches 3 is 0. Now, again, if you plug in 2.9 or 2.99 or 3.01, you get 2.9 squared minus 9. All right, 2.9, if we square it, you get 8.41, and 8.41 minus 9 is going to be negative 0.59. All right, so again, negative 0.59, that's a number that's pretty close to 0. Let's plug in 3.1 and square it. 3.1, if we square it, minus 9, okay. As you can tell, I left my calculator at school. Get 9.61, and if I take 9.61 and I subtract 9 from it, I get 0.61. So again, it's another number that's in there that's pretty close to 0. So the limit is there. Now, I'm going to change this problem up just a little bit. I'm going to go from x squared minus 9 to looking at the limit as x approaches 3 of x squared minus 9 over x minus 3. All right, now in this case right here, we don't really know what this graph looks like. We do know that there is a, well, never mind, we'll get to that later. If we plug in here, we get 0 in the numerator and 0 in the denominator. And what that tells us is that this does not exist. So it appears that the limit is not going to exist. But that's not entirely true here. Because what we can do here is we can actually reduce this equation. We can reduce this equation and we could say, okay, this is x plus 3 times x minus 3 over x minus 3. And then we can cancel these out right here, and we're left with 3 plus 3, which is 6. Now, I want to go here. I want to take this little bit of information right here, and let's think about applying it with numbers like 2.9 and 3.1. So, if I want to figure out what f of 2.9 is, well, we know f of 2.9, the numerator is going to be negative 0.59. And what is it that we get in the denominator if we say 2.9 minus 3? We end up with negative 0.59 over 0.1. And when we do our arithmetic here, we get that's negative 0.1, by the way. we end up getting 5.9 as our answer. All right, now let's think about plugging in 3.1. Well, f of 3.1 is, okay, I know in the numerator I'm going to get 0.61, and in the denominator I get 3.1 minus 3. So I get 0.61 divided by 0.1, and I get 6.1 as my answer here. So see, even though when I plugged in 3, I got 0 over 0, when I plugged in two numbers that were really close to 3, I didn't. But I got 5.9, I got 6.1. Those numbers are close to each other. And you would see as you plugged in 2.99 and 3.01 that you'd get two numbers that were even closer to positive 6 than that. Now, you're not always going to have a limit. An example of when you don't have a limit is if you have the limit as x approaches 2 of x plus 4 over x minus 2. See, if I plug in 2 here, I'm going to get 2 plus 4, which is 6, and 2 minus 2 is 0. That's 6 over 0. Now, let me plug in 1.9, and let me plug in 2.1. Well, 1.9 plus 4 over 1.9 minus 2. All right, 1.9 plus 4 is 5.9. And then 1.9 minus 2 is negative 0.1. So when I do this arithmetic, I get negative 59. Now, when I plug in 2.1 here, 2.1 plus 4 is 6.1, and 2.1 minus 2 is 0.1. So I get positive 61 here. So see, negative 59 and positive 61, they're not close to each other. And what actually happens here is when you plug in 1.99, you're going to get a number like close to negative 600. If you plug in 2.01, you're going to get a number close to positive 600. So they're actually going away from each other the closer our x value gets into 2. So we will pick up on more on this next time. I have to limit the videos to very short because the computer won't upload them if I don't. But we will hope you watch this video. Hope you get something. You may want to watch it a couple of times, but we will pick up on this next time in class. Hope you enjoy the snow.